All right, so today, I will pick them up in just a minute. We are going to work on Unit 1.4, okay, Unit 1.4, and this lesson is called Powers of Monomials. Powers of Monomials. So we went over monomials, what monomial means, the definition of that on Tuesday. Can anyone raise their hand and tell me what is a monomial? I have sticks. Now, hope you wrote it in your notes. So, I think, yep, that's what those notes are for. Look back at them. Can anyone tell me what is a monomial? Oh, nope, now I get to pick my own volunteer. No one volunteered to start with. Caroline, what is a monomial?
One term could be just a number, just a variable, or the product of the same variable.
Awesome, good job. So, seating chart, I can't remember everybody's names. So, Mark, what did she say a monomial was?
I couldn't understand.
You couldn't hear her? Maybe it's because you were talking. So let's give her another shot.
Okay.
Sorry, Caroline. Let's try again.
One term could be just a number or just a variable, or the product of a number and variable.
Awesome. So, Mark, can you tell me in your words, what is a monomial?
A number with a product or variable.
Okay. Now let's try in your words, not the reading off the notes of my words.
Okay, I'm confused.
You're confused. Okay, let's try. What would, in your words, Giselle, what is a monomial?
One term.
That's it. One term. Okay? So sometimes it's just a number, sometimes it's just a letter, sometimes they're attached together. Okay? If they're the product, what does product mean? Multiply. So they could be attached together by multiplication. Okay? And yes, you are right. That is a monomial. Okay? So we are going to deal with today finding powers of a power. So power of a power. Okay, power of a power. And there is a rule that you need to know. And the rule for finding powers of a power, okay, to find the power of a power, keep the base, and multiply the exponents. Multiply exponents. So keep the base and you need to multiply the exponents. So for example number 1, if I ask you to find 3 to the 4th power raised to the 3rd power, 3 to the 4th power to the 3rd power. If you wrote this out the long way, okay, the long way, what does this 3 tell you to do? It tells you to write whatever's in the parentheses how many times? 3 times. So this would be 3 to the 4th, and another 3 to the 4th, and another 3 to the 4th. What do we do when we have the same power, or same base? What do we do with their exponents? Whoa, we just did this a couple days ago. You add them, right? This would be 3 to the 4 plus 4 plus 4. Then if you add them all together, we would get 3 to the what power? 12th power. Now, that's kind of annoying to have to write it all out that way. So you can, when you have a power to a power, you can just multiply their exponent. So this would be 4 times 3, which also gives you 3 to the 12th power. Okay, that is the shortcut for doing this. So I want to show you the 2 different kinds of problems, and then hopefully I'm going to give you a trick that might help you to remember the difference. So we're still on example 1. I'm going to show you the difference between 3 to the 4th raised to the 3rd power versus 3 to the 4th times 3 to the 3rd power. Do you see the difference here? What is the difference here? Does anyone know? Court?
You're adding number 3.
Right, on this one you're adding them together. This one you're multiplying. The way that I tell my Algebra 2 students to remember this, because still I have people in Algebra 2 that they can't quite remember the difference, okay? The way, and this is not like super mathematical, okay? This is just a trick to help you remember, okay? When they're really close together, all that will fit in between them is a little multiply dot. But when they're more spread out there, you can fit a big old plus sign because there's more space. So these ones are really close and squished together. All that fits in between them is a multiply dot. But when they're spaced out like this, you have more room, so you can fit a whole big plus sign. And that's literally how some of them remember, when do I add and when do I multiply? Okay, so you are gonna have to memorize when do you add and when do you multiply. Okay, if they're squished together right next to each other, you multiply, because that's all that fits. If they're more spread out like that, you can fit a big old plus sign in between. Okay, not super mathematical, technical, but it might help you remember. Okay, so here, what would be your answer if I had 3 to the 4th raised to the 3rd power? 3 to the 12th. Okay, and we know that because I just showed you the long way and we did it. And what would this answer be? 3 to the what? 7th. Okay, so make sure you know the difference between those because it's pretty important. Okay, in fact, most of your test that we're going to take, like in a couple weeks, still a long ways away, is going to be about this. So be kind of careful on that one. Okay, number 2. For example, number 2, I would like you to multiply c to the 6th power raised to the 7th power. C to the 6th power raised to the 7th power. C to the 6th power raised to the 7th power. So according to my rule, what am I going to do with these exponents? Am I going to add them or multiply them? Wait for it. Andrew. Drew. Sorry. According to my rule, what do I do with those numbers? Am I going to add them or will I multiply them? Multiply them. So this is really going to be c to the 6 times 7, which gives us what? C to the what power?
42.
42. Thank you. Yes. Malia, yep. Malia's back. She's back on track. Now, what I want you to do is open up your book, and we're going to look at page 32. Okay, we're going to look at the got it on 32, and let's figure out, do you have it? Have you got it? Do you get it? Okay, look at page 32, and all the way at the bottom of the page, we're looking at got it, A through C. So A, B, and C. Okay, I want you guys to try that, and then we're going to figure it out if we've got it all together. Okay, figure out, have you got it? By the way, when I take out the sticks, I put them right back. So just because I called on you once doesn't mean you couldn't get called on again. So that doesn't mean, that means you can't just turn your brain off. Thank you. Okay, so we're looking at these 3 got it's. Ooh, and that last one looks a little tricky. I know, it's you do your best, okay? Do these problems in your book. Show your work if you need to. Show as much work as you need to. Are there any more homework papers from anyone? Did we get all the grades?
Okay, you just have to do 2 by 4 to 2 meters. Okay. Oh,
Yeah, probably struggling through that yesterday.
Is he just not doing anything?
He's like, I'm just gonna be more tense. He would look at the problems. He was trying to get in my file cabinet, like to get the. Oh. Because people were asking him, because they were taking quiz and answer too. I was like, I'll just get you the answers. No. He's trying to steal my keys.
Do we have to solve or just add it?
For these, oh, that's a very good question. Great. So obviously, Drew, I'm thinking that you're asking about the A portion, right? Question A. Is that the one you're talking about? Okay, so let's start with this. So Drew, what did you do to get to, what was your first step? Well, what did you do? You took the 2. Now, do we ever change this 2? No, it stays the same. What do you do with the exponents, Drew? Do you add them or multiply them? Multiply them. So 5 times 2 gave you 10. Now, I'm not letting you use a calculator, so you do not have to do 2 multiplied by itself 10 times. Okay? If you did use a calculator, let me tell you, I don't know 2 to the 10th in my head. 2 to the 10th power is 1,024. That is a lot of multiplying. So if it's not on my chart in the back, you don't have to go that far. Usually you only have to take it to like the 3rd power. Okay, with 2s, you should probably know the 4th and 5th powers, but 10th power, oh no. Okay, so this one, you can leave it as 2 to the 10th power. Okay, have we finished the B question yet? Yeah, most of you are done. Okay, what did we get for the B question? So W to the 4th raised to the 6th power. Eric.
W is the exponent of 24.
W to the exponent of 24. Did anyone get a different answer for that? No, we're all pretty happy with that? Oh, hello, pencil. Okay, so yes, and I totally agree because you are correct. W to the 24th power. How about the C question? Okay. What did we get for the C question? Amber. 3 to the 2nd to the 3rd to the 2nd. Oh, a lot. You didn't really understand that one, okay? How about, let's try one more stick and then I'll take a volunteer. Nevaeh. 3 to the 12th. How did you get that answer? What did you do? Uh-huh. Right. So since it's power to a power to a power, we just keep multiplying. So you're really doing 2 times 3 times 2. And 2 times 3 is 6 times another 2 is 12. So So you got what for an answer? 3 to the 12th power. Yay, good job. Okay? So just because I haven't shown you something that's exactly like that does not mean that you cannot do it. Okay? I also want to talk to you guys just a little bit about if you have a problem in your homework that there's not one exactly like, or that you don't know how to do, where should you look? Look at your notes, right, that I gave you. If my notes, if you don't, well, you still can't quite figure it out, where else do you think you could look for answers? Does anyone know? You can look in the book, okay? A lot of these, I don't know if you've noticed this, because we haven't really talked about it very much, but on independent practice, it tells you examples 1 through 4. Now, that's not my examples 1 through 4, but if you look back at the book, they have examples, and it's not the exact ones that I did. So you can look in the book at examples 1 through 4, and that's what it's talking about, okay? Also, just in case you still didn't quite understand, if you look at this front page, see right here? This is the website. This is what class we're using, okay? This is the book, what it's called. You can go on the website, and they have like tutoring videos and anything like that. So if you're still not quite understanding something, that's always a good resource. Okay, so use your notes first that I give you, then use the book, and then you could use this website. Okay, those are all really good resources. Okay, now let's try something a little different. So we are now we've moved on from power of a power. Now we are going to move on to something called power of a product. Power of a product. Okay, power of a product. Did we have questions in the back? Ariana, did you have a question? No, you guys just talking about something different? There's what on your table? There's an ant? Okay, well you can either put it on. It's okay. It's just an ant. It's not gonna eat your face. It's gonna be okay. You're gonna be okay. You can squish it if you need to. Okay, so power of a product. So first off, what does product mean? Multiplication. So we're gonna find a power of something that's multiplied, which kind of sounds a little funny. So I'm gonna first give you a rule. Okay, and this is, my rule is basically like the way you're gonna do this. Okay, so to find the power of a product, find the power of a product, find the power of each part, and multiply. Okay, so to find the power of a product, find the power of each part, and multiply. Which kind of doesn't really make a ton of sense until I put some numbers. So for number 3, example 3, I would like you to find 3k to the 5th power raised to the 4th power. 3k to the 5th power raised to the 4th power. Sorry, Amber. My head is in your way. If you need to, Amber, you can always like move over to a different seat if you need to see. My head's in your way. So to find the power of a product, find the power of each part and multiply. So remember I told you that whenever something in parentheses, the exponent, what is this exponent of 4, what does it belong to? Does it belong, what does it belong to? What does it go with? Amber?
Okay.
Does it just go with the K?
No.
Where else do you think it goes?
3.
On the 3. Okay, if something's in parentheses, the exponent on the outside of it actually belongs to both of these. So what you're going to do is you need to break this up. Okay, so 3, what is the exponent on my 3 inside the parentheses?
5.
Whoa, what's the exponent on my 3 inside the parentheses?
4.
Whoa. Okay, let's stop. Just a sec. What's the exponent inside the parentheses right now?
3.
3 to the what power? 1. That exponent, there isn't one on there. So that means that your exponent on 3 is a 1. So you take this and you make it 1. And what am I going to do with that 4? Does it add or does it multiply by 4?
Multiply.
Multiply by 4. So 3 to the 1 times 4. Now for the K, it's 5. And what do I do with the 4 that was on the outside? Do I add it or multiply it? Multiply it. Okay, anytime we're doing power to a power, you multiply the exponents. Now I can simplify. Okay, what does this become? 3 to the what power? 1 times 4 is
4.
just 4.
3.
And K to the what power?
20.
20th power. Now, can you do 3 times 4, 3 to the 4th power? Yeah, you could. You could do 3 times 3 times 3 times 3, or where's an easier way to find what's 3 to the 4th power? Where might you find it? The chart I put up in class. Okay, and the chart I put up in class tells you that 3 to the 4th power is what?
81.
81. So 81 k to the 20th power. Okay, that chart will always be up there. Okay, although eventually you're probably just going to memorize that 3 to the 4th power is 81. Okay, because we'll do it enough during the year that you'll just kind of memorize that eventually. Okay, I have one more problem for you in your notes. So example number 4, I would like you to take, in parentheses, -7, x to the 6th, y to the 4th, raised to the 3rd power. -7, x to the 6th, y to the 4th, raised to the 3rd power. Say again? It's a lot of parts. Now, is this still, what do we call this thing that's inside the parentheses? What's it called? Starts with an M? A monomial. Okay, so it can be made up of a lot of parts, but they're all attached to each other by multiplication. So that's why it's called a monomial. Okay, eventually we'll get into things called binomials and polynomials. But right now, monomials. So, What do you think is my first step that I need to take? Corinne. What do you think is my first step I need to take, Kara? I'll help you out. What is it? Does it help at all if I put some arrows like this? What am I doing? That's called distributing the exponent. Okay, so first thing you want to do is give that exponent to each part. So we're going to rewrite this. -7 to the what power? Third power. Well, it's like a 1, right? There's an invisible 1. Thank you for whoever remembered that. And what am I going to do with that 3? Is it going to add or multiply by 3? Multiplied by 3. Then we have our x to the what power? 6th multiplied by 3. Again, we're still multiplying. And then your y to the 4, and what is it doing with the 3? Multiplied by 3. Now we can actually work this out. Okay, so actually work this out. So remember, -7 to the 1 times 3 is the third power. Does anyone know what is -7 to the third power? Right, okay. Hopefully from my chart back there, you can tell that what is 7 to the third power? 343. How do you know if it's going to be positive or negative?
Oh, wait.
Malia? You can figure out, you could just multiply them. So -7 times -7 times -7. And you can figure out that if you have 2 of them, they go away, and there's still 1 left behind. Okay, so can anyone come up with kind of like a rule or a way to remember how you can tell if it's going to be positive or negative? It has something to do with even and odd.
Oh, no, I don't.
Tony? Nathan, sorry.
What?
Yes.
Oh, if the exponent is odd, then it's going to be a negative number, but if the exponent is even, it's
Exactly. Okay, if the exponent is even, they're going to go into pairs. Okay, like pairs, the 2 negatives, 1 pair, so 2 comes together to become positive. Okay, so it's kind of like if you're forming teams. Okay, you're forming a pair. You have a pair of negatives, they're going to become positive. But if it's odd, you ever heard the saying odd man out? Okay, it's like one person that doesn't have a buddy. So they can't become positive, so it stays negative. So anytime you have an odd number exponent, it's going to stay negative. Okay, if you have an even number exponent, the negatives are going to come together and become positive. So here, so for this one, is this going to end up being even or odd? Or excuse me, is this going to end up being positive or negative? Should this answer be positive or negative? Negative, because there's 1 left behind. And then what do I write for the exponent on x? X to the what power? 18th. And y to the what power? 12th. Okay, that's your answer. Now, before I release you, I would like you to look at page 33, and we're going to look at the got it. I want you to look at D, E, and F. Okay, the got it's on D, E, and F. So look at page 33. We should all be looking at page 33 in our books. Look at page 33 in your books. And you guys are looking at the got it's, D, E, and F. Just in case you don't have it, open them up there. Okay, look at the got it on D, E, and F. Let's do these problems to figure it out. Remember, I only need you to actually multiply the numbers out if it has an exponent of 2 or 3. Okay, you don't have to multiply. So there's one of those, you're not going to have to multiply out. You can leave it in what's called exponential formation. Exponent form. I'm going to check with you guys in just a minute or two to figure out, have we got it? And I might be strategically picking people that are not looking like they're doing it. Maybe. Maybe not. guys all done with these ones, or are you still going? Still going, okay. Good job.
And then, yeah, and I have a bunch of like big yeah. Yeah. Or if you need like any, well, I don't know, we don't have two posters, but any of those kind of posters, especially like the box, like I just put those on the top. Just like that. But I lost that.
Okay, so let's look at D. Okay, let's look at D. What did we get for D, please? What did you get for the D equation? First off, what did you do? What did you start by doing? What do I do with this 2? Thanks. What do you do with this 2? Just like let it hang out there? You give it to the 8 and the B. Okay, this is called something called distributing. Does anyone know what distributing means? Okay. Does anyone get the paper at their house, like the newspaper? You might not read it, but does anyone get the newspaper at their house? Yeah? Okay. Has anyone ever had a job, a newspaper route? Do you know what that is? It's like someone that gets up at like 3 o'clock in the morning or 4, I don't know, some crazy time when I'm not awake. And they distribute the paper, okay? But do they get the paper, do they distribute it to everybody? No. Who do they distribute it to? The ones who paid, right? The ones who are on their route. Well, this is kind of like distributing a newspaper. You distribute it to anybody that's on your route. So anybody that's in your parentheses, in your route, you give them a paper, okay? Just like this. You give this to anyone that's in the parentheses. It's called distributing. Okay, so yes, we would distribute this 2, and then it becomes what? 8 to the what power? Please. Second, and B to the what power? 9, and what do you do with that 2? Multiply or add? Multiply the 2. So if I asked you to simplify that, what is 8 to the second power? It's on my chart in the back. 8 to the second power, or 8 times 8 is what? 64. And what happens with my exponents? B to the what power? 9 times 2 is 18. Yay, good job. You're fabulous. Okay, let's try another one. How about E? What do I do for E? Magic stick says Kelsey. Where's Kelsey? There's Kelsey. Sorry, like I lost you. Oh, way to use those math words. Good job. Distribute, distribute, distribute. So this becomes what? 6 to the what power? 6 to the what power, Kelsey?
6 to the 4.
Yes, 4th power. You got it. X to the what? What do I do with the 5 and the 4? You multiply them. So that's going to be a 20. And you can skip some steps. It's okay. You don't have to show where you're multiplying. And then what about the y? Y to the what power? 11 times 4 is 44. Now, for this one, I do not expect you to do 6 to the 4th power. Okay, it's not on my chart. I don't know it. I would have to do the multiplication or use a calculator. So you can leave your answer as 6 to the 4th power. Did anyone actually find out what is 6 to the 4th power? Did anyone actually do that multiplication? Yeah? 1,286? 96. I'm just going to say that I believe you because I believe that you can multiply. So, or you could write 1,296 still x to the 20th, y to the 44th. So like on a quiz or a test, I would take either answer. Okay, but it's totally fine to leave it in this form and not do all of that multiplication work. Okay, and then the last one for F. What did we get for an answer and how did you get it? Malia.
What? Sorry, they were.
It's okay. What did we get for an answer and how did I get it for F?
You want me to tell you my answer?
I want you to tell me how you get that.
Okay.
What do you start with?
So you
Distribute.
the 3
Okay.
parentheses,
Uh-huh.
and then you get 5 to the 3rd power,
Okay.
w to the 6th power,
How did you get the w to the 6th?
3 times
2 times 3, okay.
and then 8 times 3.
Uh-huh. So what did you actually get for your answer?
I did it wrong.
You did it wrong. Let's try to do it right. How do you know you did it wrong? I haven't given you the answer yet.
I know. I did it wrong.
Okay, well what should you do? First off, is your answer going to be positive or negative? How do you know? Because how many negatives are there?
See? I did it wrong.
Okay, well how many negatives should there be?
There's one.
Negative 5 times negative 5 times negative 5. So how many total negatives are there? 3. So 2 of them group together and become positive, and there's 1 left behind. So that means your answer, overall answer, is going to be positive or negative? Negative, right. Now we can deal with the numbers part. What is 5 to the 3rd? 125, and you know that because it was on my chart. And then w to the what power? 6, and z to the what power? 24. Perfect. So you got it. There you go. Okay, that's your answer. So what you guys are going to work on now